Good day, science enthusiasts. Welcome back to our channel. Imagine you're standing in front of a large mirror that allows you to see your entire body at once. However, for some unknown reason, the mirror suddenly shatters into multiple pieces. As you observe the shattered mirror, you realize that your reflection is now fragmented across each individual piece, and you can no longer see your complete reflection as you did before. Have you ever wondered why it happened? It's as if the familiar image of yourself has been shattered into a kaleidoscope of fragmented pieces, each reflecting a unique aspect of your appearance. The captivating mystery lies in the intricate dance of light, geometry, and the mesmerizing artistry of shattered glass. In this exploration, we unravel the captivating science behind why we see different pieces of our reflection when we peer into the enigmatic world of a broken mirror. A mirror is an object with a smooth and reflective surface that reflects light and forms images by specular reflection. It allows us to see ourselves and our surroundings by bouncing light off its surface in a way that preserves the angles of incidence and reflection. The invention of the first mirror dates back to ancient times, and the specific individual or civilization responsible for its invention is not definitively known. However, polished stones, metals, and other reflective materials were likely some of the earliest forms of mirrors used by ancient civilizations to observe their reflections. Modern mirrors, those everyday objects that effortlessly reflect our images, are the result of a precise and intriguing manufacturing process that melds craftsmanship and science. While glass forms the base, it's not what lends mirrors their reflective prowess. Instead, it's the careful deposition of reflective materials, like silver or aluminum, onto the glass surface. The process starts by selecting flawless glass sheets. The real transformation begins with the application of a reflective coating. This is where the mirror's reflective magic comes to life. Thin layers of reflective metals are expertly applied to the glass through vacuum deposition, a method where the metal is vaporized and then skillfully condensed onto the glass. This creates a mirror-like surface that can accurately bounce back light, forming our clear reflections. So why do mirrors reflect images? Mirrors reflect images due to a process called specular reflection. When light hits a smooth and polished surface, like the glass of a mirror, it follows a specific rule. The angle at which the light hits the surface, angle of incidence, is equal to the angle at which it bounces off the surface, angle of reflection. This consistent bouncing of light rays preserves the direction of the light, allowing us to see a clear and accurate reflection of objects, including ourselves, in the mirror. The smooth surface of the mirror ensures that the light rays don't scatter, resulting in a well-defined image that faithfully reproduces what's in front of it. However, when a mirror is broken, you see different pieces of your reflection because the mirror's surface has become fragmented or distorted due to cracks, fractures, or other imperfections. This means that the law of reflection still applies to each individual fragment of the mirror, but because the fragments are oriented at various angles and positions, the reflected light rays bounce off in different directions. As a result, the light rays from your reflection hit these fragments at different angles and are reflected back to your eyes at varying directions. This phenomenon can be explained using the concept of specular reflection. The phenomenon is similar to how a puzzle is made up of individual pieces that, when put together, create a complete image. In the case of a broken mirror, each fragment reflects a portion of the scene, including your own reflection. Because the mirror pieces are at different angles and orientations, they can produce distorted or disjointed images of your reflection. The specific characteristics of the distortion depend on factors such as the size and shape of the mirror fragments, the angle at which they are positioned, and the nature of the mirror's breakage. This can lead to a fragmented, surreal, or even distorted appearance of your reflection as the light rays bounce off the various mirror fragments in different directions. In essence, the broken mirror acts as a collection of separate mirrors, each producing its own reflection, resulting in the fractured and varied images you observe when looking at yourself in such a mirror. And since the mirror pieces are often close to one another, their reflections can overlap, creating a mosaic-like effect where different parts of your reflection appear in different areas of the mirror. Overall, the combination of these factors results in the perception of multiple disjointed and distorted images of yourself when you look at a broken mirror. Each mirror fragment contributes to a unique reflection angle, leading to a complex interplay of light rays that produce the fragmented and varied appearance you observe. Now that we've delved into the mesmerizing science of broken reflections, it's time for you to join the conversation. What's your most intriguing experience with a fractured mirror? Have you ever caught sight of yourself in a multitude of surreal fragments, each telling a unique story? Share your thoughts and reflections in the comment section below. As we continue to unveil the secrets of our world, your insights might just be the missing piece to this fascinating puzzle.